Hi, I'm Alia Atlas, and I'm here to, tell you a little bit about what's been going on in routing in the IETF. So first, I'm going to cover a few sort of general area-wide themes. Some of these have been going on for quite some time, and so shouldn't be real surprises. Yang modeling, but we're getting to the point where it makes sense to really start paying attention. Data plane encapsulations, lots of different ones coming in the data centers, centralized orchestration, and what does that mean as we develop new technologies for control plane. And then a little bit about a couple of the new working groups that have been formed this past year, BEER and DetNet. So first, Yang models. We're seeing a lot of really good participation, particularly from operators. OpenConfig's been very active in this space and helping drive what makes sense for the models for configuration and read state analytics. I find when I talk to operators, there's usually a high interest in this because it is coming for how you're going to be operating and interacting with the routers. This is a really good chance to shape and improve what the common device configuration is. I have a lot of the routing area working groups working on Yang models for their specific technologies. A number of them have focused design teams. If you haven't taken a look at any of them, I've got a few examples down here. There's the OSPF one, a traffic engineering one, and the BGP model. All of these are quite mature and worth looking at. I can't click on them here, but if you go to the presentation, those all give you links directly to the drafts to take a look at. There's also challenges, of course, for doing Yang models, because unlike MIBs, where we're doing them piecemeal as you get new technology, we're going back and trying to do Yang models for a wide array of technology simultaneously and having them, work together and so on. So there's all sorts of issues ranging from, depending on what the device is, where it sits in the network, what kind of a network it sits on, it needs a different set of models. It would be very easy to do some models that work for different devices, and yet not all of the models that a particular device actually needs. So getting the input on which models are important is very useful. Common abstractions, trivial case, right? Router ID. Do you model as a uint32? Do you model it with dotted quad? What's a common convention? If we don't think about the trivialities, then you end up with unnecessary divergence. And so one of the tricks here is trying to avoid that unnecessary divergence. And then finally, there are questions, how do we drive the right abstractions? There's at least 3 different views coming into play. One of them, which I think is really important to bring into this and have there, is the operator view. How are you planning on using the models? What are the abstractions? How do you view what needs to be there in Yang models and for the configuration? So having that perspective. Another perspective, of course, is from the vendors. What are the implementations? And then there's a natural tendency in the IETF to do it by working group. So here, this is a hammer. Let me describe a Yang model for the hammer, as opposed to describing it for how you're using the hammer, right? I feel like the internal organization of the IETF is completely the least way that we want to actually structure the Yang models. We want to do them based on operator perspectives, and we can do cross-working group, and that's what we're doing with, for instance, the traffic engineering model. But we need your perspective coming in, and we're getting some of it, but I love having good reviews. So classifying models. We talk about models, but there are data models, they're all at different layers. So at the highest layer, not in routing, but in ops and management, there's work going on a service model. How do you do a layer 3 VPN? This is more towards a customer. Network element models. So some focused on configuration, I would say more, because that's one of the new pieces that Yang brings, but also towards learning the network. Also, dynamic APIs, because there's a lot of interest in programmatic APIs. How do you have good interactions into the routers? So again, here are some links to drafts where there's fairly significant work progressing on topology, generic topology, layer 2, layer 3, traffic engineering, RIB. So you can actually install, I like to describe it as static routes on steroids. Take all of the abstractions that you have and take advantage of them have the ability. Take a look at the RIB model. It's got some really cool stuff. Then how do these all interconnect? And how do we make sure that if you have model A that's developed over here by this group and model B over there, and they both happen to need the same set of 3 parameters, for instance, you end up with common groupings instead of slight differences. So those are some of the challenges, and one of the reasons that we need people coming in looking at the models from a how am I going to use this, how's it going to look on my routers type of perspective. Coordination, as you might have gathered by now, is one of the things I'm quite concerned about. So we've got a mailing list, which anyone can join, of course, which is basically for folks who are interested in talking about and coordinating about the different Yang models related to routing. It's got a number of routing folks on it. It has some Yang doctors on it. It's a good place to come with questions. I have a routing Yang architecture design team that I chartered, which has been working for almost a year now, looking at what are some of the common things, how should the models interconnect, what are gaps potentially in the Yang language or in our expressiveness that we actually need in order to do this and make it happen. We also have the routing area working group. That's, of course, been around for a while and it's doing all sorts of stuff. But one of the things that it's good for also is being a forum for routing-related Yang models. And you can see a number of them that are down there that don't quite fit into any of the other working groups, and yet we need a common place to talk about them. So that's Yang modeling. It's been going extremely heavy. I mean, we're talking well over 100 Yang models being worked on simultaneously across the IETF, and a large number are in routing. So that's been going on quite heavily for the last year and a half at least, and that means that a lot of those models are mature enough to take some good solid looks at. So let me go on to data plane encapsulations. Yes, there we go. So we're seeing more overlay networks, lots of encapsulations. I can give you examples. A lot of them are coming from NVO3. So whether this is VXLAN GPE or GUI or Geneve, NSH is coming out of the service function chaining work. Beer has an encapsulation that goes under MPLS. I'll tell you about that. DetNet's looking at what its encaps are going to be. Well, there's always motivations for a new data plane encapsulation, and they always look really simple to get started. All you need is to carry just this little bit of extra data. And then you start getting into the complexities. How much flexibility do you have? Oh, but if I'm doing it for this particular use case, then I can take advantage of this hardware feature, and so on. Or maybe I want to do this encapsulation, but I've got to ship it over across, I don't know if there's going to be firewalls, I'm going to do it across UDP, I have to worry about entropy and so on. What each of these different data plane encapsulations mean is that you end up with isolated ecosystems where you have to translate between the different encapsulations if they're going to talk. And to some extent, that's fine. If you have your data center in your network and you pick encapsulation A, that's great. But once people have actually taken these different data plane encaps and deployed them, getting to consensus and changing any of them is a little on the challenging side. And we all know that new encapsulations, you're adding hardware cost and delay. On the other hand, if it's proprietary, sometimes you can take really great advantage of some of the hardware aspects. I've seen a number of proposals around, taking advantage of TCP offload. Hey, we could take advantage of this, get some really good functionality, but then you're locked in. So one of the questions that we have here is how many different data plane encapsulations? So if you look here on the right, and I'm not going to bother to read to you the full list of them. You can look at them. Those are just the obvious types of considerations that you have to question when you start doing a new data plane, whether it's your entropy, MTU considerations, header protection, what happens if you want to have multiple layers of these. You have to think about all of these things. It starts simple. I could take advantage of this feature. I want to ship this extra information around. And then it starts getting complicated. So what we're trying to do is seek commonality. I chartered a design team that worked last year to come up with a list of factors to consider, and basically to encourage common solutions when there isn't a reason to have different ones. Because usually the reason to have a different encapsulation has absolutely nothing to do with congestion considerations, or even OAM. Those aren't your motivations for a new data plane encapsulation. So if we can succeed in keeping commonality in the data plane encaps when there's not a strong reason for them to be different, again, discourage divergence if we don't have to have it, then maybe we can take shape and take care of these. But one of the things that's happening here is all of these data plane encapsulations that are coming into the IETF already being out in the marketplace, already being deployed with a load of isolated ecosystems that are making it hard to look at. And maybe that's okay. Maybe you all are happy having a selection. But then we need to know that, because usually, I know we all joke that the great thing about standards is there are so many, but we try not to have a vast number that do the same thing. So how many do we need for different purposes, for different transports, for different environments? When we say hardware friendly, what do we mean? Turns out hardware friendly is very different if you're thinking about TCP offload versus what a core router can do. Understanding that many routers, for instance, only have access to so many bytes at the start of the header. They can't necessarily handle TLVs, but TLVs are great for software. There's a lot of different pieces here. So in addition to saying, these are the complexities, here are common ways to do it, I also have a new design team that started up, which is looking at overlay OAM. Again, the motivations for all of these different encapsulations have nothing to do with the OAM, but you need OAM. So let's see if we can make some of that common. I'm going to speed up a little bit. Centralized orchestration. Obviously, there's been an industry movement towards software-defined networks, having a lot more centralized orchestration, whether your favorite's OpenStack or OpenContrail or ODL, OVSDB, lots of different options in this space. Of course, some of the IETF technologies like PCE, PSEP are being used. And we've provided improved interactions to routing, for instance, learning topology with BGPLS, a lot of interest in BGP flow spec and extending it for traffic direction. The question, when we start looking at what kinds of new control planes make sense for some of the new technologies, should we just do a model? Do we just do a Yang model, use RESTconf, NetConf, that's how you interact from an orchestrator and you're done? Maybe you need slightly more APIs, some of the I2RS extensions that we're talking about for NetConf and RESTconf. Do we need model-driven control protocols where you can either do it with NetConf and RESTconf, or you can do it with a specific protocol? Do we continue to just reuse the existing protocols and develop those in parallel? I've got at least two working groups, SFC and NVO3, where they're starting to talk about what makes sense to do in the control plane. And this is being driven by how you're building your data centers and what makes sense to you. So those are some of the themes I'd like you to think about that are impacting what's happening in a number of the working groups in the IETF in routing. Now let me tell you about a couple fun working groups that have gotten started. The first one's beer. And beer is it's just neat technology. It's the first multicast packet encapsulation that I've seen. Multicast specific, you can use it for interesting things. And it's targeted initially at MVPN. Idea is to remove multicast state and control state from the core of the network. But you can also think about what could you do if your network didn't have to care about massive scale application layer multicast. Where could you go with it? Of course, it's really neat, and it requires hardware changes or a software implementation. So at the moment, the work's going ahead experimental because there's a lot of open questions. Does it actually simplify your operations? Is it useful enough to deploy? Are the gains for it worth it? Can we get past the challenges so that it's really useful? Let me tell you the basic idea. You take all of your edge routers, and each of your edge routers gets assigned a bit in a bitmap. And each packet carries a bit string which corresponds to the edge routers that are supposed to get the packet. You may say, oh, but I've got a lot of edge routers. Yeah, so then you can do a trade-off between ingress replication and duplication in the core. It depends upon how long your bit string is. Think of a default as, I think they're talking 256 bits. Fine. So each hop, you look at the bit string, and you look at a new forwarding table called a BIF. And I'll show you what that looks like on the next page, and replicate out to each of the neighbors the necessary neighbors based on the BIFT. So no per tree or tunnel multicast state. The BIFT is forwarded based on your shortest path to those particular destinations, so you're not dealing with reverse forwarding state and so on. Here's an example. In this case, you can see a bit's been assigned, D is 1, F is 2, E is 3, A is 4, and B wants to send traffic. And so for instance, if B wants to send traffic to D and F and A, B is going to look at its bit index forwarding table. It'll say, oh, I'm going to look at the first bit, which is D. Great, I'm going to send it off to my neighbor C, and that's going to take care of also sending it to F. So now I only want to send it to A, so then that's the only bit that's left set. I'll go off, okay, I'm going to ship it directly to A. So you duplicate it. Obviously, there's this lovely architecture that talks about this in detail. For all of the details you can get there, but that's the basic idea. Take a bitmap, assign routers, do a lookup, and this goes into a bit of the details on how to do the packet forwarding. What this is the worst case number of replications a router has to do is based on the number of neighbors it has, as opposed to the number of bits, and it works, right? So the questions are not around the core of this technology in terms of functionality. The questions are, is it deployable? What do you need it for? In a world where there's a lot of migration away from multicast, what are the uses? Is it worth changing your hardware to do this? For some networks, for some data centers, it may be. For others, certainly not. Finding what that balance point is. It's a new working group. It's been going about half a year. And there's a lot of enthusiasm there. If that sounds interesting, go take a look at a couple of the drafts. Next new working group met for the first time in November is called DetNet, or deterministic networking. Similar to things we've been through before, but this time with a more targeted purpose. So this work's coming out of IEEE 802.1, time-sensitive networking, which grew up out of audiovisual and industrial uses. Ideas, not just layer 2, now we want to do a mixture of layer 2 and layer 3. You have deterministic flows, and when I say flows, I also mean multicast flows. They care about unicast as well as multicast very much, as you can imagine, for audiovisual. And the goal here is to have a way of doing reserved paths and guaranteed low latency and loss. But you're not solving the problem with overcapacity. In this case, you actually might have more than 50% of your traffic flows, more than 50% of the capacity being these types of traffic flows. So, you can set up the paths, you can do it centrally orchestrated, you can do it in a distributed fashion using, for instance, RSVPTE, and then you have to worry about knowing enough on the network to set it up with the pre-reserved buffers. They have a lot of use cases. They're busy investigating different technologies. For instance, you could use MPLS to identify your flows. There's also interest in IPv6, of course. Maybe you use DSCP to identify the flows. This also interacts with 6TiSH and Internet of Things, where, again, you end up with tracks which describe how much resources and bandwidth are associated. So it may tie into that as well. You can use a path computation element, the PCE, in order to do your computation. We're probably going to need additional information beyond what's currently being shared out in IGP about device resources. And the basic architecture, it's preliminary, it's not even yet a working group draft, I believe, is giving a few techniques that are already working in the layer 2 networks. So they're getting started. Obviously, this is targeted at particular focus, but some interesting work and building on a lot of the IETF technologies. So those are a couple new working groups. Now let me talk a little bit about improving IETF work, because as we all know, doing open standards, the first thing you hear is it takes time. It feels slow. Part of that's because it's stability. When you're building a foundation or a staircase, people want to make sure that they're not going to have to come back and rip it out later. And so there's that impact. And of course, it's volunteers. And volunteers with different competing priorities, that usually means that when there's a crunch, it's the day job that wins. That's life. Then of course, there's also consensus. And getting to consensus takes time. I'm sure you're all familiar with the challenge of, say, trying to go out to dinner with, say, a group of, say, 5 or 6 people. No one wants to offend each other. Everyone has a small opinion, but not a strong one. And it just takes time to figure out where you're going. Sometimes some of the IETF process feels like that. Everyone has a little bit of an opinion, and it just takes time to get to that consensus. Been encouraging very much, one of the reasons we do consensus, right, is to make sure that we don't miss legitimate technical concerns and issues. People have different ways that they're going to use the technology, different concerns. Anyway, but the key point that I'd like you to take away is that if you, as operators, really want some technology, it can move. And we have, it can go quickly. We have an example with BFD over lag. I think it was less than a year to go from here we really need this to multiple interoperable implementations and out the door. So what happens here is operators end up being a useful forcing function for this is what's needed. I've, of course, been working on improvements, particularly in the routing area, encouraging conference calls, basically, for working groups, so we get that high bandwidth communication going and resolve issues. Things don't stall out. We're all familiar with, oh yes, we'll get around to talking about that next IETF, trying to make those conversations happen sooner, whether it's on the list or in virtual interims. Keep the momentum going. Been doing training to coordinate across the area and to get working group chairs onto similar pages and think about how we're running the area in our particular working groups. Those are all up on YouTube also for anyone who's truly fascinated. And finally, we can move drafts through the process quickly. The biggest factor with moving drafts is responsive authors. It's not the process. We're moving drafts anyhow. The issues tends to be there. So there are some reasons pieces are slow or can be slow, but much of the time, we can get stuff done when it's clear that it's needed. So this is your standard. Of course, why should you come be involved in the IETF if you're not already? And for those of you who are, that's awesome. So the first reason I like to say is, well, you understand your networks and what your needs are a lot better than your vendors. And if you leave it up to your vendors to represent your thoughts in the IETF, well, they're proxying multiple people, and they have their own opinions too. But you know what your network needs, and if that communication doesn't get through, it's not always clear what the right technology solution is. So you know your networks a lot better. It gives you a chance to have an impact and make the internet work better. You really can come in, read a draft, send a review, and make an impact. Have it fix a problem. When you come in with a good perspective, it doesn't have to take a lot of time. Another reason, isn't it nice to find problems when they're still in the draft stage instead of in your network? And you have to, sorry, Rudiger. I mean, let's be honest here. If you read the draft, you might pick up on something that just doesn't match up with your operational or deployable reality, Or will you look at it and you say, they haven't thought about this topology. This topology always causes problems. Let's fix it. You can fix it in the draft before it's implemented, before it's deployed, and before you have to figure out workarounds. I'd like to claim we have the technology perfect, but no one does. So, and then the other piece is, as I said, operators serve a forcing function in the IETF. You say what's needed, what's useful, what's deployable. There's a lot of, well, you could do this. Describing it as gap filling is a little harsh, but nonetheless, when you have an operator or multiple operators coming in saying, this is a real use case and I really need this, that tends to focus the mind charmingly. How to get involved. The first thing is, it doesn't have to take a lot of time. I'm sure you all know people who have spent a lot of time doing IETF stuff. And you know, that happens to be our choice. It's not the only choice, and it's not what's needed. What's needed is people who are operators, who are doing their day jobs, who are running their networks, who nonetheless can spend a little time to read an interesting working group draft. And you know what? If it's not interesting to you, don't comment on it, because we want what you choose to review, what you choose to comment on, has an impact and gives an indication of how useful that draft is. Okay? You can join a relevant working group list, listen, comment. Maybe you don't read it every day, every week, every month. When you do, you get some perspective. You don't have to read it all. Another piece. When you come to conferences, you always joke what a small world it is. All the people you know, oh yeah, I saw you this conference. You find out that you're friends of friends of friends, no problem. It's the same way into the IETF community. I'd be stunned if all of you don't know at least somebody who knows someone who's active in the IETF and who would be happy to help you out. This isn't a strange foreign organization or hard to get involved in. And if it feels that way, you know me now. I'm happy to help. So, 3 specifics. IDR, they're working on BGP flow spec. One question is, should it be based on the associated Yang model, so you've got the same functionality in flow spec that you'd be able to do via RESTconf and NestConf as via BGP? There's, I don't remember, 5, 6 different BGP flow spec drafts out there for augmenting it with new functionality. If you're using it and you care, this is an easy one to comment on. NVO3, the data plane encapsulations. Yeah, the working group has adopted 3 different data plane encapsulations. Having some input as to which ones you like and why, that would be really useful. What kind of OAM you care about, also useful. And finally, one entertaining topic that came up last IETF from V6 Ops, IPv6 multi-homing in small enterprises. How do you handle that with BCP 38 filtering? What's the right solution there? Is this a real problem? Is it an issue that comes up only if you're a V6 purist? What are your thoughts in that space? So those are just 3 specific things that came to mind that I thought you all might have a thought in. Thank you very much.